Typical remote piano lessons utilize video conferencing to deliver instruction. This limits the student and instructor's view and makes it difficult to properly observe playing technique. We present HoloKeys, a piano education interface for remote learning. HoloKeys allows educators to deliver remote lessons by playing a holographic piano, simulating in-person teaching. Their interactions are played out in real time on a physical piano remotely located with their student. This allows the student to observe live demonstrations on their own keyboard just as they would in person. The system is flexible and capable of fitting almost any piano by using a customizable clip system. Remote students connect HoloKeys to the keyboards they already own, allowing them to receive direct physical demonstrations of the music they're learning. HoloKeys aims to help remote music education move beyond desktop-based learning and into the physical world. In this section of the video, we'll cover the hardware aspects of our HoloTouch device, HoloKeys. We used a variety of microcontrollers, servos, and input devices in order to create our project. We will discuss how these devices work together, as well as technical challenges that we faced, like controlling 8 actuators at once, or finding a power supply big enough to power them all. We use the Magic Leap as our primary input device. The Magic Leap actively scans the user's surroundings and builds a mesh of their environment. We use the Magic Leap's gesture recognition to build a realistic user interface for pressing piano keys. When a key is pressed, the device relays the information over the internet. We'll talk more about that later.
The ESP8266 is a Wi-Fi enabled microcontroller. This device served as the bridge between our Magic Leap input device and our actuator output. However, there were not enough control pins for all the actuators we used, and the power supply was too small to control them.
So we had to get creative.
The PCA9685 is a 16-channel servo driver with an external power supply.
This driver board provided plenty of connections for all of our actuators, and its external power supply provided all the power that we needed.
We used a variety of software to make HoloTouch, including Unity, PubNub, and Arduino IDE. We worked together to model the piano in Maya, texture it in Substance Painter, and animate it in Unity. When a key is selected, a message is sent to PubNub to move the piano key and the animation plays. Our code recognizes hand gestures and sends the appropriate message to PubNub. The Arduino code establishes a connection with PubNub. Then it checks the channel for messages which instruct the servo to activate. When a message is received, the microcontroller sends a message through the servo driver instructing the correct servo to turn, delay, or perform other functions.